Hello and welcome back to another video. Today we're going to be looking at the final Calc BC 2019 FRQ free response question for those of you who are illiterate. And now let's just get right into it. All right. A function f has derivatives for all orders for all real numbers x. A portion of the graph of f is shown above, along with a line tangent to the graph of f at x equals 0. Selected derivatives of f at x equals 0 are given in the table above. Alright, these are some weird derivatives. Like, I don't know about you, but negative 23 halves is really kind of popping out to me as a number that's probably going to be contrived to work out with an alternating series error bound. Yeah, it just pops out a little bit, you know. Right, the third degree Taylor polynomial for f about x equals 0. Polynomial sub f of x super 3. And what's that going to look like? Well, we know the Taylor polynomial's got this the nth derivative of f of x times x minus a to the n, where a is a center, over n factorial. Right. Yeah, you should have come into this test knowing that. All right, so let's get right into it. It's going to be, well, third degree Taylor polynomial. Well, let's start with the first thing. So about x equals 0, we know that the first thing is 3, because that's the 0th derivative of, yeah, 0 derivative of f. It's going to be 3 plus another 3. Or wait. Should have seen that one coming. Now, actually, it's the first derivative is going to be negative 2, as you can see by this line right there. It looks kind of like negative 2. So negative 2 times x, because it's minus 0. We're not going to write minus 0 to the 1. We're not going to write to the 1 power. That's dumb. I nearly accidentally wrote 1 factorial. Oh, yay, my export's complete. No, I don't want to view it. Let's get back to it. I nearly caught myself writing 1 factorial back there. It's going to have to not happen. So, yeah, and then that's going to be plus 3 times, what does that look like? Let me scooch this thing over a little bit so I can actually write 3 times x to the second power over 2 factorial plus, and it's third degree, so we just got one more. Oh wait, you would have thought I was writing plus. It's actually negative 23 halves times x to the third over 6, because that's equal to 3 factorial. All right, that's that. Or is it? No, it's not. We still have more parts. Let's get back to it. Part B. Write the first 3 non-zero terms of the Maclaurin series for e to the x. Alright, that's light. We know that e to the x is just this summation from n equals 1 to infinity of x to the n over n factorial. Everybody should know that. I think it's, yeah, you're definitely taught that in school. Anyway, so that's going to be first 3 non-zero terms. Looks like it's x to the first over 1 factorial plus x to the second over 2 factorial plus x to the third over 3 factorial. That's going to be x plus x squared over 2 plus x cubed over 6. Alrighty. Now also write the second degree Taylor polynomial for e to the x times f of x about x equals 0. So, looks like we're just doing some quick multiplication. Actually, wait a sec. This is actually n equals 0, not n equals 1. So forgot the 1 plus there. Whatever. Alright, so let's get back to it. E to the x times f of x is going to look like 3 plus negative 2x squared plus, what's that? It's 3x squared over 2 times x squared over 2. So 3x to the fourth over 4. Alright, light work. Now, looking at C, let h be the function defined by h of x equals integral from 0 to x of f of t dt. Use the Taylor polynomial found in part A to find an approximation for h of 1. Alright, just going to be the integral from 0 to 1. So, integral from 0 to 1 of f of t dt. Looks like it's just going to be, how are we going to do that one? Integral from 0 to 1 of f of t dt. Well, if we're going to do that, basically we're going to end up looking for, yes, the center's A is going to be different, right? So that'll just be, use that Taylor series, right? So that'll be just f of t, integral of f of t. Oops. Integral of f of t from 0 to 1. Well, that triangle right there looks like it could be about 1. And this square looks like it's 1. You know what? It's 1. Alright, part D. It is known that the Maclaurin series for h converges to h of x for all real numbers x. It is also known that blah, 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 blah. Alternating series error bound. Okay. Approximation in part C. I did this on the test, and I got it right, definitely, like without a doubt. I'm gonna have to pull this up. Well, that's not the right one. Looking at question 6. All right. Question 6. Oh, you just have to like wait. Oh, you just have to put that in there. You just have to put that f of t into like the integral. Alright, well, looks cool. I'll just put the link to it in the description below. I haven't even finished recording the video yet, and I still said the description below because that's what it looks like it'll be. Anyway, yeah, in case you're not going to check the description, here it is. You're welcome to check that link out, and have a wonderful day.